So I guess we can start. The goal of today is to finish this topic about testing, and then you can start. I will release the homework for this topic on Friday or Saturday, but you're given again 2 weeks to do it, and the goal after that we talk about ANOVA, which is the second to the last topic. After that, we'll regression, and that's conclude the whole course we are talking. So I think last time we did all the tests in Excel. So what is left here would be to use the add-in. Okay, use the add-in to handle the hyper testing. Okay, so here what we will do is to focus on the 2 sample case, and we will do the Excel add-in so as to see how work on those. Okay, so to get started, I open Excel. Okay. Okay. So what we'll be doing is I'm trying to follow what has been done here. Is I try to have the data like this, and then I would do the test. Okay. So what I'm going to do is I just save the file first, and then we will be working out the hypothesis testing, and it will be add-in, and it will be 10th of November of today's days. Okay, and I have 2 column x1 y1 or x1 x2, and the data we are using is just I copy from the slide. You can do whatever number you want to, but I just try to be consistent. Okay, so this data we have. Okay, so what we want to do is to use the add-in to do the 2 sample tests we want. Okay, so we do a independent T.TEST. Okay, and we have the equivariance first, equal bar. Okay, so that will be our first job. Okay, so to do it, we have to use add-in. Add-in is being the data. Okay, and you can see from this, we don't have the install yet. So if you use Windows, I guess actually some of you use Windows. Okay, and it would be file, options, and then add-in. Okay, file, option, add-in, and then I have to add this NS2 pack. So I go to the manage in this one. I go to add in this guy, and then I click the button and OK. So the Mac will have some similar feature to add in because I don't use Mac. So but I think we have do this last time. So here we comes with the data analysis. Okay, so I think Mac will have a similar feature. So data analysis, what we're trying to do is we're doing the T.TEST. It's equivariance, so it's the third to the last entry. Okay, third to the last entry if you use the window. Okay, so just highlight this guy, and it will give us the entry. You can see the variable 1, variable 2. So basically this, you input the first one. Okay, and give the first column, or just highlight the first 7 cells. Okay, I just being simple, just add the whole column there, and add the whole column there, and the hypothesized difference, and this is 0 because that is usually what we do. We test the difference. Okay, and labels is with the first row of label actually we do. Okay, and alpha is we have 95%, so that's a standard thing we do. It's 5 alpha, and output just decide to tell them where they are. Just put them next to the result. So that is Once we're done, we just tell them the column A and column B, right? And tell them what's the difference and put the label there, and then we're done, right? It's very simple. Just click, okay? And automatically it produces the things we want, okay? So you can see it tells you all the mean, the variance, the count, right? The put of variance, right? You remember the put of variance, right? The put of variance comes from this variance and this variance, the weighted average. So it must be between these two numbers, weighted by 5 and 3, right? N minus 1, right? Just to make sure you know what to do, right? Will be just this guy minus 1, right? Times this guy plus the N minus 1 times times this guy, okay? And this is the numerator, and the denominator is over sum of the weights, which is N1 plus N2 minus 2, okay? So that's how you get this guy. So you shouldn't be an issue for you to reproduce this one, okay? And degree of freedom is N1 plus N2 minus 2, right? So then you can calculate T.STAT, you can order the p-value, but here do note that the p-value is the left tail, okay? And that is different from the T.TEST from that gives you the right tail, right? If you remember what we covered last time is T.TEST, okay? We can also do the same, input the first row, first column and second column, and you pair one tail, and then we put 2, okay? And okay, interesting. Okay, they also give you the same. They also give you the one tail. Okay. I guess they give you the one that is smaller one. Okay, so that should be fine. So same. This is the same here, and you can use the two tail. That also use two tail. They should give you the same answer. Okay. Okay, so that is what we have for the add-in T.TEST. Is that okay? Is that how we found this? And alpha actually comes from the T inverse, right? T inverse of 2,5, and degree of freedom is just this guy. Okay. Or one tail test, so it's just 0.5. 0.5 here. Okay. The reason this is one tail, and you can also do the two tail. And maybe I put the T.STAT as well. T.STAT will be just the difference between the mean, okay, over the square root, okay, of the put-up variance over N1 plus the put-up variance over N2, okay, and so this is what we have in the everything in the slide. Okay, maybe if you want, you can just this plus this minus 2. Okay, this is how you calculate it. I think we don't need to show you how you can calculate the mean, right? Okay, so that means that every entry you know how to do calculation. Is that okay for the first one? Is it okay? Any question? I just go around because to see if any problem, or in case you use the Mac, is it any question? It's okay. It's okay. I think slide have that one, right? Yeah, this is here. This is showing here.
I'm looking at the questions from like the earliest slide.
I see. Let me know if any question. Just go around. If you have any problem, is it okay? Is it okay? Is it okay? Okay. So if you do assignment, this might be one way to know you are doing right or wrong. Okay. So I also want to show you the other one, okay, which I would look at the unequal variance. Okay. The unequal variance is coming from the same idea, but everything is calculated differently. Okay. So we again do the data analytics, okay, data analysis. And what we do is this T.TEST two sample assuming unequal variance. So second to the last one. Okay. And I click OK. And again, I tell them what is the range. So it's unequal variance. Okay. And I would choose the column A. Okay. And also column B here. Okay. Is that clear? Variable 1 is column A. And then column B. Okay. Actually, same thing, right? And then I tell them I have the 0. Okay. And I have a label there. And that's it. And I tell them where to put it. Okay. Is that okay for this entry? So you tell them the first column, the second column, and tell them the mean difference are 0, and tell them the data of labels, because the first column are the labels. And then once you click OK, okay, then you can immediately see everything is there, right? So you have the T-stat, you have all the things. The degree of freedom is 7. This is 8, right? A little bit less, but you can easily see how you can do calculation. And to check if you understand this thing or not, you should try to see if you know every single entry there. Okay. If you're able to calculate everything in this table, then you mean you understand. If you are not, then you don't. Okay. So the only thing probably you would be, let me show it to you how you calculate everything there, right? The only difficulty is this guy, right? This guy. And this guy is simply a complicated object where you have the this variance over n1, right? And s2 square over n2 square, okay? And raised to the power 2, okay? This is the numerator. If you look at the slide, actually this is the case, right? S1 square over n1 plus s2 square over n2 and take overall square. That is the numerator, right? And then the denominator will be s1 over n1 square, 1 over n1 minus 1, okay, plus 1 minus n2 minus 1, s2 over n2 square, okay? And let us do the denominator thing, okay? That would be bracket, okay? S1 over n1, okay, square over n1 minus 1, okay? This is for the first entry in the denominator. Okay. Okay. Is that okay? This is for the first entry for denominator. And then I add the second entry denominator, which is s2 square over n2, okay, and square it, and then over n2 minus 1, okay. And once I enter this, that give me the, okay, this give me the okay, this is the formula, right? This give me the 7.02, and when I run down, it just give me 7. So for the rest, I think should be easy. Okay, I can produce this guy for you as well. So this is just mean of x minus mean of y, right? And over square root, okay, of this over this guy plus this over this guy. Why this is true? The reason is this formula is given by x1 bar minus x2 bar, which is the numerator, and the denominator is just square root of s1 square over n1 plus s2 square over n2. Okay. Okay. So that is how you calculate these two. Okay. I think the rest will be simple. Is that clear how you derive all this thing? Because this is I hope at this class at least you know each single number, how it comes about from this table, because you would not be doing the calculation by hand anyway at the end of the day, right? So if you know which number comes from where. Okay. No, not to memorize. You just need to know where it comes from, where you can find the formula. Oh, you don't need to memorize, but there's a formula there. You just need to know this is coming from this formula. Not to memorize it. Oh, that is no need, because no one will remember, because too many. If you learn, there will be way too many formulas. There's no way you can remember. I mean, this is just very beginning. So if you notice, if you learn afterward, there will be more than 100,000 of formula. There's no way you can remember. No need to remember. So you just need to say, okay, for this one, that's why I open both, because there's no point to remember any formula in this kind of thing, because it's like too crazy. Okay, so just need to know, okay, this is come from this formula, then you're done. Okay, I'm not saying that you have how to calculate, but you just need to know, okay, this formula come from where it comes from, then that's important. And same actually for when you later you learn statistics, you just need to know where it comes from. Of course, you probably good to know what's the reason behind the formula, but sometimes it's like too many things to understand, for sure. I mean, since you're a business school student, so I'm not expecting you to remember everything. Okay, is that okay? So I guess I have there's the formula there. I guess one more, last one is the paired mean. Okay, so this is the last one. That's why I want to talk about that one. Okay, and then we go to ANOVA. Okay, so the last one is pair T. Okay, and I think it's simple enough. Just let me take the. So this is the data. Okay, I have x1 and x2, which is 3, 4, 2, 5, 6, 7, 3, 2, 6, 4. Okay, I'll just do it because just to be same. So this is a pair sample. It means that I'm looking at the difference between the two, right? I can simply just do the difference and do the T-test, right? So that's simple. But Excel has a add-in to do it directly, right? So I go to data, okay, and data analysis, and then I go to the fourth to the last one, which is the T-test, looking for a pair sample, right? And then again, the same thing, I just put in the first column, and I put in the second column there, and I tell them the difference is 0, you can put any number, but we just test that they're the same. And there's label there. We put 5% as usual. Output range is D1. So this is how we handle it. Okay. We just put them, tell them the column 1 is the X variable, column 2 is Y variable, and then we say the difference is 0, and the labels are there. Okay. And we're done. Is that okay? So just click OK. Okay. And we're done. So very quickly, okay. We're done. Okay. So this is just the standard T-test. Okay. So I guess everything is not very surprising to you. The only thing is this guy. Okay. Probably is something you would be a little bit surprised because they also give you correlation. Okay. But this is just, you know how to handle that guy. It's just CO. Okay. It's just the correlation of the 2 columns. Okay. So just formula, which you learned in topic 2 already. Okay. Although I didn't say it out, the thing we learned is called Pearson correlation. Okay. And if you look at my textbook, they tell you there's other one we often use is Spearman's correlation, which is basically you just care about the ordering. Okay. Here, basically that one is also correlation, but you rename the number of the data from highest to lowest from 1 to the highest number become 1 and second number become 2. So we just reschedule the number and calculate correlation. Okay. So anyway, but that is what you learn in this class is only the Pearson correlation. Okay. And there's another one called Spearman, but that you don't need to learn about it. Okay. You recover it when you learn categorical data analysis. Okay. So what we learn is just the Pearson version. And everything is very simple, right? The T-stat is just simply, okay. T-stat is simply just x1 minus x2. Okay. And the variance is a little bit complicated. Okay. How do you calculate the variance of this? So the first thing to do is calculate D first. D will be just you need to calculate a column called D, and D will be just x1 minus x2. Okay. And this is the D. Then we need to calculate the T-stat. It just okay will be the difference between the 2. Okay. Over the SD of the column C. Okay. Over the STD. Okay. And remember, this is not done yet. You're over the root n. Okay. 6. Just 6. Okay. So why is the case? Let me explain again. So why you get this formula here? The reason is being this is maybe it's better not look at this one. Better to use the. You can use the average. That's better, because that fit your slide better. Okay, so this is just D is just the numerator, just D pi, right? And that will be S of D over root n. Okay, so this is average of the D, so that's just the numerator, right? And this is the D will be S of D. Okay, so the square root of 6. Okay, so that is the formula how you calculate this from scratch. Okay, and I guess the rest would all very clear. Okay, is there any problem? I hope at least you know how each number there comes from your slides. Okay, of course, you don't really need to really remember the exact formula, but you need to know, I mean, why they're there, right? Okay. Any question? If no, then we will go to the ANOVA. We'll finish the hyper testing. You can, I will upload the homework tomorrow or Saturday so that you can try to work. You are given, I think, more than 2 weeks. 2 weeks to do, more than 10 days. Okay. And after this homework, and then this only the last one. So last 2 topics, regression ANOVA will be 1 homework, single homework. And that's it. And remember, we don't have midterm, right? So that's why homework has to be done in some way. Otherwise, to make sure you study, right? Otherwise, you don't know whether you know it or not. Okay. Okay. So later I will put these slides on the put this Excel file on the Blackboard. You can check it out. Okay. If there are no questions from you, then we will talk ANOVA. Okay. Maybe let me give you a brief overview what ANOVA is. Okay. ANOVA is very simple. ANOVA is simply the T.TEST of many groups. Okay, for purpose. Okay. T.TEST is comparing 2 groups, whether they have the same mean. Right? Remember, the T.TEST we do is independent population. We want to see if man is different from woman, say in terms of the hours watching Netflix, say for example. Or you look at department store, is it men spend more than women? Or look at the restaurant, is it the elderly spending more than the junior people? Right? So we just between 2 groups. Okay. The problem is what happens if you more than 2 groups, right? It's very natural you have multiple groups, and you want to compare how different group behavior. For example, in our school, we have 8 colleges, right? Six or 8? I don't know how many. 9. Oh, 9. Sorry, I was at my time only 4. So I mean, okay, 9 colleges. Then we need to see, say, is it 9 colleges people are same having the same spending pattern, or they have the same social work-life balance? Okay, do they party often? Right? Because when I was a student, the Saul College is far away from everyone, so that means that Saul College is have a more hall culture than the rest, right? So you want to check the difference. And here is I don't know how different now, because I'm no longer a student, and but you want to see what the difference, right? Or in Hong Kong case, you can imagine that I don't know whether you go around, but you will notice different part of Hong Kong is very different, right? The Hong Kong Island is different from the Kowloon Peninsula and different from the New Territories, right? So there's a 3 group rather than 2, right? So you want to check the 3 groups are different, okay? So here we will assume, again, what we have is a bell curve, right? So just look at the whiteboard here, right? So what we have in the T.TEST, right, is the following, right? We have one group of X1, right? X1 bar, right? There's a population 1, right? And population 1. Right, population 1, you have a bunch of people, and your mu1, right? And that look like this, right? And we have another one, right? Population 2, okay? And we have X bar 2 and the bell of mu2, okay? So with mu2 here, okay? So the T.TEST we have before is try to see if these 2 are the same or not, right? X now is mu1 is equal to mu2, right? We have done the Excel, we just did that, right? And And also we look at two special case, right? Whether this sigma the same or not, right? This is what we have covered, right? So now what we want is, instead of these two, ANOVA is allowing us to extend to any number of groups. Okay, so I want to have population 4 or 3, sorry, 3 first. Population 3. Okay, I have and I have mu3. I have sigma 3 square. I want to have another bell here. Okay, and that is mu3 here. Okay, and I have x bar 3. So what we want to see is these three things are the same. Okay, the h now, the question is mu1 equal to mu2 equal to mu3? So is the three groups are the same? Okay, and that is what we want to do. Okay, although you may say we have many things to ask. Okay, but in this multiple group cases, we just want to ask one simple question in our class. We just want to see if all the means of each group are the same. Okay, and historically, this is a very important idea when you do experiment, right? You can imagine that a farmer, okay, try to see different way to grow the crops, okay, or do different cross pollination, right? And the different combination of amount of water, amount of fertilizer they use, amount of sunlight they have to use. And in that case, they have different combination. And the first thing they want to see is if all these things matters, right? If all these changes doesn't matter, then they can be very relaxing, right? They don't need to be worried too much, right? Do they make a difference, right? Or in terms of medical tests, right? You want to not just compare two groups, right? You compare multiple groups, right? And see if different dosage, different combination of treatment, medical treatment, will make a difference to the outcomes, right? So these are the main problem. So just let me repeat what we are doing is we are generalizing a two-tailed t-test for two groups to many groups, okay, to multiple groups. Here, the first thing we do is we focus on this one-dimensional group, okay? Is either group 1, group 2, and group 3, okay? Each group has one dimension, okay? And after that, we talk about second thing we call two-way ANOVA, which cover next week. We will talk about is each observation need not be characterized by one group, okay? Can be two dimension. For example, as I mentioned, we talk about college in CHK, right? Everyone will belong to one college. There's a 9 possibility, but everyone assume normal. I mean, I have male and female, right? Or maybe for inclusive, you have maybe can you keep the voice down a little bit back? Sorry. So yeah, can you keep a little bit yes, can you keep the voice a little bit down? Sorry. So you can also have the male and female and all other genders, right? You can have genders and college. Okay, everyone can be characterized in gender and college, or everyone can be characterized by, say, year 1, year 2, year 3, year 4, and different colleges. Okay, so that is two-way ANOVA. Okay, so that is what we want to cover. So as I said, today we only cover in this particular case is each agent observation is only grouped by a single dimension. That's why we call one-way ANOVA. Is that clear what we are trying to do? Okay, and I would say the computational stuff is very heavy here. Okay, there's no way in this world you're going to use your computer to do it. No, sorry, use your hand to do it. You use a computer anyway. So the important thing is you understand there are many terminology here. You need to understand what they are. Okay, of course, in the slide I will tell you how you calculate, but in the world no one actually calculates it by hand. Okay, the Excel will do it. I mean, even Excel, you don't do the calculation. Actually, you just click one button and comes out the answer. Okay. So the only thing you need to know, most likely, is understand what they are. Okay. And this is different from what previous before. We're not doing to do the everything from scratch. Okay. And okay, let's get started. So this called analyze of variance, and in short, you will see in math textbook it's called ANOVA. NOVA is ANOVA. Okay, so that is that's why this topic is called ANOVA. And and as you will see, this is many people will say this is a special case of regression, which we cover in the next topic. Okay, so that's why you seldom see people talk about regression. Okay, so one way ANOVA. Okay, so how do we describe data? Okay, so far the data what we have is x1, x2, x3, right? But now instead of x1, x2, x3, each data have to be telling you this is the value of the observation, but it tells you which group they are also in. Okay, so each data will become a pair. Okay, so what do I mean by that? Is you look at, maybe I open Excel, that's the usual data you will get. So let me save this one. Okay, so usually the data will look like this. Okay, so for example, maybe this is the time for party. Okay, and this is college. Okay, what you have is, so they spend 3 hours for party for NA college, 2 hours for party for CC college, 4-hour party for SAW college, another guy maybe 3-hour party for NA college, so on and so forth. Okay, so each observation is not just a number there, but instead you will tell me, you record which college they're in. Okay, so that is each observation will attach the group information. Is that clear what's going on? Okay, so that's exactly what this is about. Okay, each data point is the numbers and the group. Okay, and in terms of notation, they talk about, they're called factor. Okay, sometimes they call factor, is the description of the characteristic of the data. Okay, and of course you can think the group also, male or female, is also the problem. Okay, and this is the data we collect. Okay, and usually how people write it is, this is a little bit cumbersome. How you write is, you write x11 as what we do in the last class, the double subscript. The first number represent the grouping. Okay, the second number represent the serial number in the observation. Okay, so look at this case. Okay, if NA, suppose NA is called 1. Okay, I just make it easier. NA is called 1, CC is called 2. This is this, right? So this means x11 is 3 here. Okay, and here means x12 is also 3. Maybe I change number, right? Because not to confuse, this is 5, say, and this is 5. Okay, here means x21, which is 2. Okay, and this is x31 is 4. Okay, is it clear how we convert from one data to the other, right? And this is just, usually you don't need to worry because the computer will handle it. Okay, but I just make it because you need to understand the notation used in your slide and how they derive. Okay, because you don't need to worry about this, because this is, the computer will handle everything. Okay, so basically you just use the data, I just do the add in and just come out the answer. Okay, just basically close your eye and click the black box, come out the result. Okay, but you need to understand what's going on there. So that's why you open the black box and see how you can do the calculation. Okay, but once you open it, you know it, you don't need to know it anymore, you close it. Okay, So this is how you get the data. And okay, and this is what we have. Okay. And here is something, sometimes this is the data is stored in this way. Okay. So they're stored in this way. So it means the following. Okay. If you try to transform this, this is what you get. Okay. You have NA, okay, CC and SC. Okay. In this case, NA you have 3 and 5. Okay. CC will have 2, SC will 4. Okay. So that would be sorry. Okay. So this is the data you have, and you have to know how to transform this to here. Okay. Usually the software program will tell you how to transform from here to there. Okay. But this is the data we work on Excel is exactly the one, the column DEF. Okay. So you work on this data. Okay. And of course, when you're given the data, you need how to do the transformation. That is easy. Okay. Right. Need not be a matrix because need not be the same length. You can see here NA have 2 and CC and SC have 1. So it's not a matrix, just a list of the data. It's not need not be square matrix, need not be a matrix at all. So when there is a matrix, they call balance. It's balance, but it's not balance in this one. A very good question. It's not need not be a balanced one. So can be unequal length there. Same as T.TEST, right? Need not be everyone the same number. Yeah, they don't have sample size, yes. So the length actually the sample size, right? Exactly the reason. Is that okay? Is that okay? So usually this means that NA have 2 observations, 3 and 5. CC have 1 observation of 2, SC have observation of 4. Okay. So this is data, and then we handle, right? Remember what we do is a T-test. Okay. We're doing T-test to see if the mean for each group are the same or not. Okay. So as I said, we are doing the bell curve, so that's why we need to make assumption on the bell. Okay. So here we have some mathematical notation. Okay. What it said is we assume that the classical assumption is every observation observed follow a normal distribution of the bell. Okay. And here is group I have the mean I. So this is nothing but just this. Okay, just saying that X have a bell, X2 has a bell, and white and green has a bell. Okay. And it say more than that because it's only the mean, right? But it also said the underlying is also a bell. Okay. So what it means is actually saying when you draw a sample there, right, it's actually coming from a bell. Why is color here? Okay. This thing is also a bell, right? And this inside is a bell, and the red one is also a bell. Okay. So ANOVA is assuming everything drawing from a bell. Okay. So that's the first thing. Okay. And that is the meaning of this, the equation here. Okay. And and there's some way in mathematics you can write in this way. Okay. It's called decomposition. Okay. Because this is a constant, which is a known constant, so you can write a random variable consists of 2 parts. One is a fixed part and one is a random part, right? And random variable is a random variable as well. This is a constant. Okay. It's a constant here. And a variable here. Okay. And this is a bell again. Okay. So what it means is very simple. What it means is here. Okay. It's Xij. Okay. Have mean of mu of I. Okay. So what we are doing is we consider the following. Go back to 0. Okay. And we have this guy, okay? This guy is called epsilon ij, okay? And this epsilon ij, you go back to mu I, right? The same thing, right? Because we learn normal. If we add a constant and subtract a constant, we just shift up, back and forth, right? So this is what it means, okay? And that is how this defined, okay? And why we want to define this way is because we can further define the following. Mu I, okay, is defined as mu, okay, at the treatment effect, okay. Okay, so that is what it means, okay. And what does that mean? Maybe I just draw a graph to illustrate what's going on there. Okay, so what is that? The following. So I have a this guy, and the first thing I have is, say, suppose I have group 1, okay. This is the mu1, okay. This is the x1i, okay, because you can draw many observation from this guy, all right. And also I have another one which is blue one, right? Maybe this one is here, okay. Group number 2, mu2, which is x2i as well, right? I can be a lot of observation you can draw from there. And here we have maybe we have another one, right? This is 0 is here, say 0 is here, okay. And we can actually have right, this guy, okay. We can have epsilon 1 I, okay, right? Because this is just mu1, okay. And we can also have another one. Maybe I just make it look a little bit different to make sure that it looks nicer. Okay. Okay. And I have another one, which is this is epsilon 2i, right? And this is mu2. Okay. So what we are doing is we assume, okay, then suppose the two case, we consider this is simply mu, okay, and you go from here to here, okay. This is the alpha 1, and here to here, this is alpha 2, okay. And I should use negative because it's a less than that, okay. So that is what it means, okay, because alpha is negative, so you go right. So that means that if we want to say, okay, if we want to see, okay, the null hypothesis, okay, it's more than 2 groups, right? But anyway, I think it's okay to do 2 groups in this diagram, right? Otherwise it should be more complicated, right? The thing is I want to test this guy, okay. Actually I have more, right? The same is asking the question of, is same as asking the question if this alpha 1 equal to alpha 2 is equal to 0, okay. If I asking if they have the same mean, is asking the treatment effect which alphas are all 0, okay. So that is the question. So that is a problem of the ANOVA, okay. It's looking at the what we call the grand mean. This is called the grand mean, okay. Overall mean, this is called grand mean, okay. And these are called the group mean, okay. Each group the mean, is it grand mean or overall mean? Sometimes they call, okay. Is the grand mean the same as overall mean, right? Or what we say is what we call this called the treatment effect, right? That's called treatment effect. Okay. Are treatment effect 0? Okay, so that is the goal. Okay, to see if there is a underlying the difference between the groups. Okay, is that clear what we are trying to achieve? Is that clear? Is that clear what we're doing? Is that okay? Any question? Okay. If no, then let me okay. This is what he said. Some of them is 0. Okay. So and I want to introduce the mean, then we have a break. Okay. So that's very quick. Okay. So the first one is very simple. Okay. The first one is called grand sample mean, which means that you add up. Okay. Here is over n. Okay. Is they add up for each group from group 1 to group C. C is how many group we have. And for each group I, we add up all the observations. Okay. What it means is just simply look at this data. You just add. Okay. For first, add everything up. Okay. So that's overall grand mean. Okay. The notation is being that, right, for each group, and then from group 1 to group C, within each group, you add observation from first observation to the last observation. Okay, and over n. Okay, that is very simple. The second one is simply just x bar I, means you simply within a group I, you just add from the first to the last over how many of them in the group. So it just simply means in this diagram, it simply means the average of this will give you x bar 1. Average of this will give you x bar of 2. Okay, so on and so forth. Okay, this gives you x bar of 2. It's other color, right? Okay, and do remember, if you add everything up, it's x bar. Okay, x bar is a grand mean, and each group you can calculate average. Is that clear? Okay, one is group mean, one is overall mean. Okay, is that clear? Now okay, and first thing I want to mention, last thing I want to mention before the break is they are unbiased estimator of the mu and mu I, right? Because you calculate everything up, right? The average, the grand mean is the mean that you try to estimate, right? If you look at the group, this is what you are trying to do. Okay, look at the only group. Okay, you don't focus on group. Say the income of the time they spend on party for CC college, then you just calculate the. Look at the sample of the CC college, average them, right? And you want to calculate the average party time for all the university, all the student in the school, then just average of the whole school, right? So that is the thing. Okay. After the break, we will give you the example, and we talk about how you decompose this, and at the end turnout, we will teach you do an F.TEST, and that is the goal of today. Okay. So before we continue, let's have a break. I guess we have a little bit long today, so we have a 10 minutes break. Okay. So I go around to see if any question. Based on calculation. For example, mu1 is 10, mu2 is 30, little bit. mu1 is 10, mu2 is 10, mu2 is 20, mu3 is 30, 10, 20, 30, then mu and mu1 and alpha 1. Also, they're saying that for each group mean, how they want to do it. So that the treatment effect must go to sleep. Must add everything. How your reason for overall. Yeah, that's the reference point for overall. These were presented on the is that's why we very careful. First time we run. And how actually we practice is people when so I use S to divide by the square root of we use the data the sample, yeah, you can use the sample value. So just like this. No, this is the sample, this is the variance of the sample. Not so the error of the so this is the call this is the standard what about yeah, so I want to calculate the error of the oh, and yeah, so and yeah, yeah. About the table but in the extent, you just want to use your thing is down and use the close the smallest. Say suppose the table that is 40, 50 seconds. You get only one the smallest one that largest among the one that yeah, just one. If 51, then you suppose 61, the smaller one that is this we can see the but just critical value. But you usually don't critical value commonly the two ways to do out of that. But now I'm not in the actually I'm doing the it's one that's probably you and you cannot so we should find you this one you can do this. Yes, like I can just take the probability to the 1.7 we can just take the right. But it makes it long when they just say the range. Well, okay, but I watched the recording of the output of the and the recording will say that we can use the table. Yeah, because it's an approximation. That is not in my mind for US code itself. Then that is how. Okay, so which one you more recommend? Of course, I will not ask this question. I will not have some ambiguous thing if you ask me for the fund. Like you don't worry about this. You must be able to ask because I have unless the B.B.A is not normal, then you will ask in that. And well, there are things that are confident so as makers, you know, use the detail to find we need to move. For example, if the lottery is Check against my mind. It's like I just need to one analysis. So you can remember the table. But I need to ask for 5%. I didn't ask 95. That's how we right? This one and 95. And I do that just by So you still have problem, I guess you can ask me after the class. Okay, I will stay behind. Okay, in case you still have question, because I'm afraid to continue. Can't cover everything we want to cover. So just to remind you what we have been doing, we have some sample means, okay? So these sample means of the grand sample mean and this sample group means, okay, is unbiased estimator of what we want to estimate, okay? And that is the example, okay? Here, the example I have is a nice matrix, okay? Because I have a equal number of observation for each group, and I said it need not be the case, okay? So here I have the data. Maybe I should change next time. I should change it to an equal number, okay? Here I have a grand mean. It just add up all 12 numbers divided by 12 is 4, right? And group 1 mean is just adding up the column divided by 4, okay? I think it's clear for these slides. Is that okay? I'm not going to calculate one by one, okay? And the next thing is, again, the ANOVA, okay, is asking whether they have each group mean the same, or is there any treatment effect, okay? The treatment means the deviation of the group mean from the grand mean, okay, overall mean. Each group, the group mean is different from the grand mean, okay? And as we said, that's useful in talking about experiments and talk about compare customers from different countries or different groups, okay? So what is the idea behind this? The idea is what we do, we will compare variance through the F.TEST, okay? So the idea ANOVA is using an F.TEST instead of T.TEST. So that's why we done F.TEST before. Okay. So we explain later why F.TEST would make sense. Okay. But the first thing is you notice is we will do a variance comparison. That's why we call ANOVA. Okay, variance. That's why we need to come up with the variance first. Okay. And okay. And the key to do this calculation is they're the same variance. Okay, that's the key. Okay, so it means that we have the diagram may be a little bit I have to change a little bit to make sure that this is fitting what we want. Okay, we need to focus on the case where the same variance. Okay, so that means that this is the same graph here. Okay, so that is actually the assumption we have behind. Okay, we have to make the same variance in order to make the ANOVA work. Okay, so we have to make each group have the same variance. Okay, so that means that this is actually a special case of the case one of the two sample hypothesis testing. Right, we focus on where the assumption we have is sigma 1 square, right, is equal to sigma 2 square, right? So that is what is assumed behind the same bell. Okay, and let's go back to here. Okay, so later you will see that one will play a crucial role because we look at the variance thing. Okay, so here we have bunch of calculation. Okay, so it will be you will see how we can do this method. Okay, so the first one is called SST. Okay, which is for each observation. Okay, you minus the overall mean. Okay, and square. It's called SST. Okay, and what it means, right? It's very simple, right? It's just each observation minus 4, take a square, right? This is just if you do the variance of the whole data set, that is the numerator of that part. All right. So later you will see this is the numerator variance. And the second one is what we call the SSG. Okay. This is comparing. Okay. You can see is okay. You look at the difference of SST and SSG. Okay, different is you just simply replace this guy with the group mean. Okay, instead of using each observation, you replace each observation by the group mean. Okay, so what you're calculating is in this one, there are no variance within the same group because each group you replace the data with the group mean. Okay, so what is measuring from this SSG is how each group, okay, is different from the other, right? How this one group are different from the other. The second one, SSW, is looking at the same, but you replace this guy. Okay, that is what SSW is asking how each observation different from the group mean. Okay, it means that you don't care about the other group. Looking within group. Okay, so this is within group difference, right? This is between group difference. Okay, and you can see actually can be proved. We're not proving it. Turn out to be you can decompose the total variation, okay, equal to variation between group and variation within group. Okay, so it's always you can decompose it in two parts. Okay, it's the variation between group is same as variation across group. Okay, so let's see the graph. I think this this diagram will be good to explain what happened. Okay. And what we have is, okay, this data we have, okay. This is X1, okay, can distribute like this way, the bell like this way. And X2 is like here, right? X is like here, and X3 is like here, okay. And how can you calculate SST, right? SST is look at this data point, okay, and you look at the distance between the mean and square, right? And you can also look at this guy, come to here, right? So this is every observation, take a distance to the overall grand sample mean and square, okay? This is SST. And SSG, okay, is looking at, okay, between group, okay. So you don't care about this anymore, okay. You just everything become this guy. So it's the distance between the group mean and the grand mean, right? So there's SST. And SSW instead is looking at each observation to its own group mean. Okay. So that's why SST is decomposed in two parts. Okay. To its own mean and from its own mean to the grand mean. Okay. So let me give you another point. Okay. So focus on group number 2. This observation here, okay, this value here. Okay. This to this area to this line is called SST. Right. And maybe I use the same color as the I think I use this one, right? This point, okay, you calculate to here is SST, right? Take a square. And if you take this point to here and square, it's called SSG. Okay. Sorry. From the mean here to this is called SSG. Okay. And from each point to its own mean is called SSW, is within. Okay. So that's why you can always, for each observation, the distance from it to the grand mean can be decomposed in two parts. Is from it to the group, right, is SSW. From the group to the overall is SSG. Okay. So let me repeat. So the variation from each observation to the overall grand mean X bar, which is SST, can be decomposed into two parts. First, from each observation to its group mean, which is SSW. Okay. Then from the group mean to the overall mean, which is SSG. Is that clear? Okay. So we always can decompose it into this part. Okay. This graph is trying to illustrate that, but it requires proof. Okay. But we don't do any proof. Okay. But you can check out the slide if you want to prove. Okay. But this is what we do. We say the decomposition. Okay. Is that clear? Okay. And you will see these three values, okay, actually will be the center of our ANOVA. Okay. This will be the most important thing we'll be doing for ANOVA. Is that any question? Is that okay? Is that okay for this one? Okay. Here I just illustrate how you can calculate SST. I'm not going to do it, but just to say the overall mean is 4, right? So what we're going to do is 1 minus 4 and then 1 minus 4 here, and then go down, say 2 minus 4 here, and then 4 minus 4, right? Just make sure that I just circle one more, and then you see, you just add up everything that become SST. Okay. Is that clear how this slide is about? Okay. Again, I said you don't need to worry about the calculation. Usually everything is done by the program. Okay, you don't need to do anything. Okay, is that okay? So, and then you can do the SSG. Okay, SSG you can see. Okay, is because x1 is 2, x bar 2 is 5, and x bar 3 is 5, and x bar is 4. So that's how you can see I have x bar here. Okay, and I replace 2 is here. Okay, and I have green is here. Okay, so that's how you end up with 24. Okay, that's how you how you calculate, right? Because you're looking at from each group mean to the overall mean. Okay, and the last part is each observation of group 1 minus the group of mean 1. Okay, and this is group of the mean 2, and so on and so forth. Okay, okay, and here we can verify that SST is equal to SSG plus SSW. Okay, this is just an example trying to show you this is true. Yes. Okay, very good question. Since you asked, I will just teach you now. Turn out to be very simple, so don't worry. I was intended to do it at the later stage, but I can do it now. Okay. So, so we have group 1, group 2, and group 3. Okay. I have 1, 1, 1, 2, 4. I have 3, 4, 5, 8. I have 2, 4, 5, 9. And I'll talk about this again, but I just quickly go to this one. There will be go to data and data analyst. And you can see here we have ANOVA, single factor. Okay, the first one in the data analysis. And you just tell them what's the input, ABC column. Okay, and label in the first row, tell them the output there. Then we're done. Calculator, no. Okay, here you can see the this is the SS, so this is the fee number there. We'll talk about this when we talk about Excel. And you probably ask how we do in the exam, right? The thing, if you check the last year, what I do is I just ask you to fill up this table. I delete some number and you fill up the number. So, and since 1 hour, I guess you would not unlikely to be asked to calculate all this kind of computer heavy thing. So my purpose is not ask you to who is the fastest computer. Okay, I'm not going to have a competition on who do the calculation faster. So it should be something you understand. So don't worry about calculation. Okay, so we will not be focused on calculation. Okay. So I hope I convince you this is not, you can see everything is there. Okay. So actually the goal of this topic is to make sure that you understand every entry here. Okay. So actually the goal is try to see what's meaning by this. That's the goal today. Indeed. Okay. So anyway. Okay, so this is SST. So that's why the first inequality SST, SSG, SSW, right? So it's here, right? Add up together. Okay. Now, the next is we call the MST, MSG, and MSW. Okay. So what are these things? Okay. Remember, Xi are bell curve, right? Xij is following bell. X bar also a bell, right? Xi bar also everything is a bell, right? So just to remind you that all these are bell curve. Okay, these are bell curve. Okay, of course, these a bell, but they're different variants, right? So this will have this over n, right? But anyway, everything is a bell anyway. Okay. So the main idea is this, okay? All this kind of measurement of sigma square. Okay. So MST is this one, okay, a standard measure of sigma square, right? Because you don't talk about the group. Each observation minus the mean and square divided by n minus 1, right? This is just the sample mean, this sample variance, right? If you don't look at the groupings, right? Look at all the data, right? And calculate the distance between its overall mean and square, it's just the simple sample variance, right? So nothing. And what is this one? Right? This one is simply looking at again how the mean of each group, right, compare overall mean, right? Again, this is also a measure of sigma square. Okay. And MSW, okay, is also doing sigma square. Okay. 3 of them are doing a sigma square thing. Okay. So how can we use this idea to, because we can compare group, right? Because we can compare variance. Okay. So that is the main thing what we're trying to do. Okay. So just to repeat is you divide this by n minus 1. Okay. The reason is very clear why we divide n minus 1. Okay. And the second one here is we divide by c minus 1. Why? Because actually there's only C of groups, right? C groups. So just actually the variation comes from C minus 1. Right? Because there's 3 groups, then only 3 different number difference. Right? So this C minus 1. And MSW, okay? Why this? It's because actually you estimate C sample mean. Remember I said how many things you estimate, you have to subtract how many of them in the denominator to be unbiased estimator, right? For sample mean, you estimate 1 in general, that you have minus 1. That's the first one. The last one, you estimate C of the group mean, right? X bar 1, X bar 2, X bar 3 up to X bar C. How many group mean you estimate? C of them. So you have to subtract from C there. Okay? So that is the free estimate of sigmas, okay, square. Is that okay? Why that? Okay? So now we basically ends, okay, before we end, this is the calculation, right? We have SS, TSS, GSSW, and it just minus n minus 1, C minus 1, n minus C. You give this free quantity. Okay? Is that okay? So what we're actually doing, okay, is compare MSG and MSW. Okay? Is if grouping has no meaning, okay, then okay, these 2 measurements should be the same. right? Because the different way to measure sigma, right? MSG is what? Measuring things between groups, right? Looking at each group 1 and group 2 have the different variance or same variance, right? And NSW is within each group, what's the variance? Okay, so the idea is, maybe I just put here, maybe the graph. Okay, it's comparing these two in some sense, right? MS is still the same idea, right? You're comparing these two numbers, right? And if, okay, if everything is this is very close to each other, right? If this is if the group mean have no difference, right? If every group very close to the grand mean, then SSG should be very small, right? Compared to SSW. SSW is within the group, right? That's regardless of grouping, SSW will not be 0, right? And if the group mean is very close to the grand mean, then SSG is very small. Okay. Let me repeat the statement. Okay, it's very important because once you know, then we're done. Okay. The idea is if the grouping has no meaning, okay, the SSG will be very small, right? Supposed to be, right? And if this, you compare these two, the measurement, and I should have this measurement, the variance measured from this one, right, should be less than this guy, right? So that's why the measurement of this is MSG and MSW. So that is why the F.TEST is comparing MSG and MSW. MS is talking about each group mean to the overall mean, right? Within group, right? Between group, right? Is between group, right? The group difference. SSW is within the group, whether the group different from itself, right? Okay, so that's why it's a one-tail test. It's a one-tail test. So that's a different from what we learned before. It's a one-tail because we only care about the case where the other way around is wrong, right? Because we want each group is very different. Right? If each group is very different from each other, the group variance will be very large compared to the variance within itself, right? Because the difference must be each group should be very different compared to the difference between themselves. Okay, is that clear what it means? Just let me repeat. It's just talking about the F.TEST about the difference. Say about looking at NA, right? We compare the difference between, say, average people in NA and average people in SAW, average people in UC college. Look at the difference between these means, right? If this is big enough compared to, say, variance within NA, variance between SAW, variance between CC, right? If the difference between the group is large enough, then you would say the grouping will make sense, right? There's grouping there. The grouping will be meaningful. Okay, so that's right tail test. Okay, so here it's very simple. Okay, we just calculate the MSG over MSW, right? So then once you calculate that one, okay, then this guy, okay, you compare to F C minus 1 and minus C, okay, which is compared to 9, okay, because C is 3, N is 12, okay, and you can easily see how we can do the F value, right? Because This is what we have. Okay. What we figure out is the number is 2.347. Okay. And the critical value you can find is, remember, we only do one tail. Okay. For this one, sorry, one tail. Because the X alternative is, okay, the variance larger, right? So you only reject on the right hand side, right? Because the X now, right, the X alternative, right, X1, right, should be the MSG, right, is greater than MSW, right? Okay, but anyway, so that's the thing you look at, right? So you can either look at critical value, right? This is 5%, so you can use the F inward, okay, 0.95, okay, 2 and 9, okay, that is how you get the number. Okay, so I can use F dot inward 0.95, 2 and 9. Okay, so it's 4.2 something. Okay, so it's here, so you can't reject. Okay, which means that you really cannot reject that the same. Okay, so you can go further, or same you can do the p-value, right? Is F.TEST the same thing? Okay, and before I end, I want to convince you that all these things can be done quickly, right? If someone asks, okay, how can you do all these things, right? You can see everything is here, right? MS, F, P, and critical value. Okay, so I guess some kind of relief for those of you worry about calculation. Okay, unless for your assignment, I guess you don't have to worry. I mean, assignment you can do it also, right? I'm not going to check it. Okay, so I see you next week. Remember your assignment due tomorrow. Okay, and there will be new assignment soon. Okay, so I see you next week. Have a nice day. See in the page 14 is number of grouping. Oh, I see it. At the beginning of the slide. Number of group. Okay. Is that okay? Pumpo? Okay, have a nice day.
Can I?
Yeah, please.
For MS